Okay, I'm going to welcome you, but we're going to have to wait just a second. There are some technical difficulties with the link that Dr. Carlson received, but I'm going to go ahead and get us moving in the right direction. Welcome and thank you for joining us this afternoon. I'm Joanne Brasington in Marketing and Communications for the college, Wofford College, and I'm grateful that the Wofford Wellness Center and the Department of Health and Environmental Control are sponsoring this event with support from Information Technology Services and Marketing and Communications. I'd like to welcome Dr. Lisa Carlson, who will be on any minute now. She's the Regional Medical Director of the Upstate for the Department of Health and Environmental Control. Dr. Carlson earned her bachelor's degree in biochemistry and Spanish from the University of Georgia. She holds a doctorate in medicine and her master of public health from Johns Hopkins School of Hygiene and Public Health. And she's completed training in internal medicine at Dartmouth Hitchcock Medical Center. Dr. Carlson has decades of experience practicing internal medicine and working in the field of public health. And we are really fortunate that she has agreed to share her expertise with us as she answers questions pre-submitted by Wofford students. I'd like to give a special shout out to students for the questions and for giving so much thought to the health and safety of our community. This event will last no more than an hour. If you cannot stay for the entire webinar, we will post a link in the next Conquer and Prevail e-newsletter, and we'll make the recording available on the college's YouTube channel. I am getting several really kind messages from people offering to help in their area. And one is from Amy Lancaster, and I am promoting her to panelist right now. And Amy can talk a little bit if anybody's interested in learning more about study abroad and how the vaccines will be helpful for traveling. So Amy, take it away.
Love an opportunity for a shameless plug. Thank you, Joanne. I just wanted to reach out because we've been getting some questions about interim travel and vaccines and what students should be doing. And obviously with news about the Delta variant on the rise, we're encouraging all students to get vaccinated, but particularly those who are planning to travel either this fall or during January, because quite frankly, the travel restrictions and requirements for entry are a moving target, and countries are going to begin probably requiring vaccines or requiring quarantines if you are not vaccinated. And so we feel like it's going to be best if all students who plan to study abroad either in the fall or in January, or obviously moving forward, receive that vaccination. And of course, there will be some countries where that will actually be required for entry. So we'll be keeping all of you posted about those requirements, but I just wanted to make you all aware that that is something that will be expected.
Thank you, Amy. I appreciate it. Dr. Carlson, welcome.
Hi, thank you.
I'm really happy to see your face. And, I have already given you a really nice introduction. So just be assured that you have been introduced and welcomed, and I will let you just take it away.
All right, let me see if I can pull in my my presentation. That's the main thing. Thank you very much for the opportunity to speak today on what is an incredibly important topic, that is the COVID-19 vaccines. And I really appreciate all the interests and the questions that have already been forwarded to me. I'll do my best to answer them. If I haven't answered it to your satisfaction, I am happy to try to do this again, an in-person one if the situation allows. And I also am happy to answer questions afterwards through the Wofford COVID@wofford.edu emails. She can forward them to me, so that would be great. All right, let me see if I can bring you into my PowerPoint here. Let's see. Okay. I believe you can see it. I just need to make it into an actual presentation. Okay, I just wanted to touch on a few things today. I can't begin to cover the scope of what is COVID-19. But I thought it was important to at least brush on what the disease is, the demographics it affects, and then of course, focusing particularly on ways that we can prevent illness, mainly through vaccination. So this came from the DHEC website, and anybody can see this. This was updated data as of July 25th. This tells you the scope of what we have experienced in South Carolina. There have been over 600,000 people who have had coronavirus infection since the beginning of this pandemic. Over 23,000 people have been hospitalized related to the illness, and unfortunately, over 9,000 have succumbed to the illness. And you can see what we call an epi curve, or the epidemic curve here. When it was first discovered back in March, initially there were a few cases, and then you can see how it quickly spread in the summer of last year. And then there were these waves that we expect with pandemics. And the largest one to date was in the winter, when people were congregating inside and many people were susceptible to the illness. We experienced a marked decrease in infections nationwide and statewide in the late spring, early summer, and it was wonderful. And it was in large part related to vaccination, and also, I think, to some people having already had the illness and developing some natural immunity. But that is how epidemics evolve. And unfortunately, now we are experiencing a new rise. And I'll talk about that more. COVID is a very serious illness for many people, not everyone. Typically, the older people are affected worse. This is a radiograph of a typical COVID-19 pneumonia, and where there are these white patches in the lung fields that should be mostly black, where the x-rays could penetrate, showing good aeration. Unfortunately, when the lungs become really inflamed, it's the same kind of thing as when you have a cut and there's the fluid, the serosanguinous fluid oozes out and it gets swollen and inflamed. That happens inside the alveolar sacs, and you just can't breathe through that. You can't have adequate oxygen and carbon dioxide exchange. And that can unfortunately lead to long-term consequences. Even if you survive the initial severe pneumonia, you can end up with scarring and requiring oxygen and other measures for long periods. We're not sure how long. Some people have recovered, and that is obviously good news. And we're working on treatments all the time. I say we, but I mean the medical community. There's also other things associated with coronavirus. I mean, it causes severe clotting problems in many people who get in the hospital. It causes kidney failure. And then even in some relatively mild cases, there are heart problems. Certainly in people who are hospitalized, they often have heart problems. This is related to a study that was done in professional athletes, where they had some very strict screening criteria for returning to play. And it was published in the spring. And this shows that even very healthy elite athletes who had some relatively mild symptoms were susceptible to some heart inflammation. Now, nobody died in this group, and it was a small number. In the next slide, you could see the way the study shows that 789 athletes who had tested positive underwent further screening. They had blood tests for heart damage, an EKG, and then they had an echocardiogram, which is an ultrasound of the heart. Based on certain criteria, then if they had abnormalities, they went on to have a magnetic resonant image of the heart, and that was the determining study for whether or not there was evidence of actual inflammation of the heart muscle or the sac around the heart. So most athletes didn't have any trouble when they went back to play, no problem. 5 of the 789 athletes did have some evidence of inflammatory changes in the heart, and they were held out in terms of playing for a little bit, and they were okay. I think I don't think that it's been reported about their long-term follow-up, but at any rate, they didn't have a major heart rhythm issue at the time or something. Now, I alluded to how we're having far worse transmission. This is a map that you can find. It's called COVID Tracker, and it's on the CDC website, which is compiling all the epidemiologic case data from the country. And unfortunately, just a month and a half ago, this was blue. But now the red and orange represent areas of moderate to high transmission. And that's based on the numbers of cases per 100,000 people that are being discovered every day. And it's actually by the week that it's looked at, particularly when determining what's going on, because you want to see trends, not just a single day. And then also the percent of tests which are positive, which indicates whether or not we are testing adequately, really, to get ahead of the curve. Now, in terms of vaccination, I'm going to kind of switch a little bit back and forth. We have some information about the upstate and the numbers of people who are fully vaccinated. We need it to be higher. Right now, we're looking at, it's about like the state average. About 50% of people have had at least one vaccine, but less have had the complete vaccination series. And I'll talk about why that's important in just a minute. You can see that some counties are a little bit ahead in terms of how well people are protected, and we'll probably see those counties have slightly less transmission, but I don't know that we're anywhere close to where we need to be to prevent the new variant that's circulating, the Delta variant, from really taking hold, which it already looks like it's doing, unfortunately. So as a result of the dramatic increase in cases over the last month, the CDC noted that we've had a 300% increase nationwide from June 19th to July 23rd. And these are people who went and got tested and had an abnormal test. So they're almost certainly infected. And these are not, we are careful with the way we report this data. And then more of these cases then are related to the Delta variant, which has been in the news so much. There are many variant strains out there, and we're randomly sampling some, and we're choosing others to sample as needed, as indicated clinically. It is at least twice as transmissible as the original strains of the virus. So that's why we're seeing it just take off in terms of, and what does that mean? That means that where previously, one person might have infected just another couple, that might be that they're infecting 4 more now. So you can see the exponential spread. So now, unfortunately, even fully vaccinated persons are recommended to wear masks in public indoor settings in these areas of substantial or high transmission, or depending on personal factors. And personal factors include whether or not you're immunosuppressed yourself or at high risk for complications from coronavirus. Or perhaps you live with somebody who is or who can't get the vaccine for whatever reason. Unfortunately, some fully vaccinated persons are becoming infected. It's still a small percentage, but there is some evidence that they could have enough of a viral load, I think with the new variant, that they could even be contagious. And so that's another reason the mask guidance has changed. When we talk about masks, we mean masks that fit well to the face. They have, it could be cotton or layered. They have to cover the nose and the mouth so that the air that you exhale is filtered. And I know there's been a lot of questions about, are masks safe? There is really no good scientific evidence that they're not safe. So to put it another way, if you were to reuse the same mask day after day after day and not, clean it, it could trap bacteria and get something growing on it. But if you change it, if you clean it, or if you have a new disposable mask, there is no reason to think that they're going to increase your risk of infection. And also, I know sometimes people have discussed whether or not it might lead to reduced oxygenation. There's no reason to think that, as long as it's not a tightly fitting like rubber mask or something. And nobody's suggesting something that makes it difficult for you to actually exchange oxygen and carbon dioxide like you're supposed to. So it just has to be a filter. It's not perfect. No measure is going to be perfect. It's just that it's one measure we can take to help protect each other and ourselves. Now, in terms of the severity of the disease, I've already mentioned that by far, older people are more at risk for severe disease and death. And this graph really illustrates it. This is from South Carolina data on hospitalizations from March of 2020 to July 24th, 2021. And you can see that the average age of hospitalization was 65 years, the median age 68 years. So that means 50% of people were younger and 50% of people were older. But nonetheless, you can also see that there were some younger people who have been hospitalized. In fact, around 4% of people under 30, not 4% of people under 30, 4% of people who were hospitalized were under 30. So no, not 4% of people under 30 were hospitalized. I want to make that clear. And unfortunately, there have been many people who have passed away from COVID complications and disease. It is mostly people who are older who have passed away. There were some younger people, though, who have died under age 30. It's not completely benign illness. At least 39 people under 30 died since the beginning of the COVID pandemic. Excuse my phone ringing in the background. Now, COVID in young people, child COVID cases, and that's slightly variable in the way that it is described by certain states. Some states have it age 17, some 18, so it's a little bit different. But generally, these are the very young people, and you can see that there has been a sharp increase just recently. And people who are younger can get infected. It's not that they can't get infected. Young people tend to have much milder disease. That is absolutely true, but it's not totally benign. The disease itself can cause, of course, acute illness where you feel bad for several days and have a high fever, body aches, headache, nausea, vomiting, diarrhea, cough, all those things. Rarely, some children have what's called multi-system inflammatory syndrome. And this is a pretty severe inflammatory reaction. And it happens, it's triggered several weeks after the initial infection. We have seen this type of thing before. We have something called Kawasaki disease, which is similar but not the same. And it was related to some infectious insult, and then children would develop heart inflammation and actually aneurysms in the heart arteries. So that the aneurysms aren't the same in terms of what happens with multi-system inflammatory syndrome, or MISC, but there are some resemblances. And these children, when they get admitted to the hospital, they're quite sick. They end up having cardiac shock. They're sometimes placed on total life support. It's not completely benign for the children that experience this. Most children survive. We have some medicines that we can use that help them recover, but 123 children have been documented to have this syndrome here, even in South Carolina, since the start of the pandemic. Now, we are absolutely fortunate that we have effective vaccines. Severe disease and death are now mostly preventable by the 3 available vaccines, which is absolutely amazing. I don't know everybody's background who's listening, but I was one of the last people actually, I should say, one of the first of the generation that didn't have to have a smallpox vaccination, because we have eliminated smallpox because of vaccination. Vaccines have saved millions of lives, and they can still, if we keep using them when we need to. And we're really lucky that we have these 3 vaccines that are available in the United States. 2 of them are mRNA based, and those are made by Pfizer or Moderna. And 1 is a vector vaccine, and that's made by Janssen or Johnson & Johnson. And I should say, I have no, they're not paying me to say anything positive about them. We can see from these graphs that are on the CDC website that show the disease, new cases reduced as the fully vaccinated population increases. It was really an amazing thing to see, and that, I think, really largely correlates to the vaccination. From those are data from December to July. Many people, I'm sure, have the question of, why do I need a vaccine if I already had COVID-19? Well, one of the problems is we can't really predict accurately if you are susceptible or not to the virus. Up to now, we haven't really had a widely available blood test for commercial use that is able to accurately predict that. So other viruses that are around, I'll give an example, hepatitis B virus. All healthcare workers are either given the vaccines or their titers are checked, and the titers are a quantified level of antibodies that are present that we know are protective against infection. So other viruses that have circulated in humans have such antibody tests available. There are antibody tests out there right now that check to see if one has been infected or has antibody to the spike protein, which is what our vaccines are focused on at the moment. But we can't really quantify the level of immunity yet. There are research-based tests that are used when they're trying to describe whether or not a new variant is going to be covered. And those are in vitro. That means they're not in a body. And they use them and report them in the news, but we're not yet sure that we can predict. So I just want to make that clear. The natural immunity could wane over time. And in fact, I'll show a slide where they've looked at that in Denmark. It happens with other diseases too. I mean, we can get reinfected with all sorts of illnesses when our natural immunity wanes. Vaccines there's suggestion that they tend to cause a protective response that may be broader than the initial infection, which is good. That's not always the case, but the ones that we have look like they will provide, for example, protection against many of the other variants that are still out there and being looked at. So this slide is from an article that was published about the population in Denmark, where people were tested by the standard PCR tests of the nose for evidence of reinfection. So some people who were infected in the first surge or the first wave last year, early last year, were followed then and rechecked 3 to 6 months later. And if they were infected, basically it was calculated what their risk of reinfection was. In general, it was about 80% protection from reinfection. So most people were protected 6 months after the first time they were infected, but not everybody. And then they did some imputation methods, some statistics, and they tried to say, well, does it vary by your age? And in general, it looked as if older people might not maintain the same immune response after, so they might be more susceptible to reinfection than younger people. And I don't have the slide up or information up, but there is also suggestion that the more severe your initial illness is, the more protected you are against reinfection. So there is some suggestion that if you didn't have many symptoms the first time, you're probably more at risk to get it again. Okay, so do the vaccines protect against the new Delta variant? As far as we know, the 3 vaccines available in the United States are protective. It's not 100%. There are what we call breakthrough cases where someone who has been fully vaccinated and still becomes ill. It's not common though. I want to emphasize, you really need both doses of the mRNA vaccines. The Pfizer or Moderna vaccines require either a 21-day or 28-day interval between 2 doses to really gain the maximum benefit from them. The J&J vaccine is a 1-dose vaccine, and you have to wait at least 14 days. It takes time for your body to build up immunity. And so that's why we use the definition of fully vaccinated as 14 days after the 2nd dose of either a Pfizer or Moderna vaccine, and at least 14 days after the Johnson & Johnson vaccine. There was a study that was published from England showing that 2 doses of the Pfizer vaccine were effective, but you needed the 2 doses. In this slide, the BNT162B2 area is the Pfizer vaccine. The other one, the ChAdOx1, is a vaccine that is not available in the United States. It's made by AstraZeneca. But the BNT162B2 is related to the Pfizer vaccine. And that data they tried to look at the prior circulating alpha variant versus the Delta variant and decide if the vaccine was effective against symptomatic illness. If you only had one dose of the Pfizer vaccine, the BNT162b2, well, you had like a reduced risk of infection, but it was less than 50%. And there was a difference between the Delta and the Alpha variant. The Delta variant was a little bit more resistant, a little bit better able to escape the immune response than the Alpha variant. Once you got 2 doses, they were about the same, and it was extremely effective against illness. And so far, our data in South Carolina mirrors this. I say so far because, science and the public health science is changing, and that's why it's extremely confusing, and we need to look for reliable sources of information. The recommendations will change based on the information that we are acquiring and analyzing. The South Carolina Department of Health looked at the cases that we had in the month of June. Not every case that was reported could have their vaccination status determined. But of the ones that could be determined, 93% of those persons who were infected with COVID were not fully vaccinated. So the vast majority were people who had not had their full vaccination series. Now, some of the people who were hospitalized had been fully vaccinated, but still the vast majority of people who were hospitalized were not fully vaccinated, 86%. So of the 166 people who were hospitalized with COVID, where the vaccine status could be determined, 86% were not fully vaccinated. Similarly, among the people who have passed away from the illness, most were not fully vaccinated. Well, how do vaccines work? They help your body, your immune system, recognize a new antigen, which is usually a protein. Sometimes it's like a protein and sugar combination. But so an example, probably everybody has had a measles vaccination or chickenpox vaccination, a flu vaccination, or they've been sick before. Your immune system is amazing. You have B and T cells, which are created when you are infected with a pathogen, a new virus or bacteria, and those hang around in your body for many, many years. And that's part of what it is that keeps us immune. So those B and T cells are out there, and the B ones are the ones that make the antibodies, which are these little weapons that go out and actually attach to, usually to the pathogen, and they activate other pathways inside our body to help eliminate the pathogens through different pathways. So if you have a new pathogen and there's no antibody there, then it becomes a problem, and your body has to use other measures to try to eliminate that pathogen. And that also, at the same time, it initiates the production of antibodies, but it takes longer to do that if you haven't been primed by a vaccine. So a vaccine helps your body already get ready. It's like giving it a weapon that it can use when it does encounter the enemy. In the past, vaccines were a tiny, weakened, like non-dangerous fragment of an organism, or a protein, or maybe even the viral vector like the adenovirus that helps push that little piece of protein into the immune system cell so that it starts that reaction. More recently now, we've got these fantastic mRNA, messenger RNA vaccines that actually use your cell's machinery to make a copy of that spike protein. And the spike protein is the most critical protein that allows the SARS-CoV-2 virus to attach to your cells. And those antibodies help block that. Vaccines protect the individual and protect the community, because there are even community members who have been vaccinated. Not everybody responds the same, right? So some people get immunity. Everybody is a unique, special person. And because of that, not everybody gets the same immunity from a vaccine or an infection. So the more people nearby who have been immunized or are immune, the better protected everybody is. And there are, of course, some people who can't get a vaccine because they have an allergic reaction to the components. So really, it's protecting the person and the community. I wanted to address some of the myths and facts about some of these vaccinations. The messenger RNA vaccines do not enter your cell's nucleus. They cannot change your DNA. Instead, they actually deliver instructions for your cells to create the protein. So here's a little picture of the DNA molecule being unwound, and then the RNA polymerase creating a little RNA transcript. This is just a cell biology slide from the genome.gov website. And that little RNA transcript then goes down and it forms the messenger RNA, and that moves to the cytoplasm, so outside of the nucleus. And at that point, the RNA transcript, the mRNA molecule, is attached to by the ribosome complex, which allows for the creation of a protein peptide. It's a phenomenal thing that's happening all the time in all of our cells. And the messenger RNA vaccines use this system in your immune cell to create this peptide that is similar enough to the spike protein of the COVID virus that your body starts reacting to it in an effective way to prevent illness. So the next slide is basically saying that, and that's from the CDC. It's a nice graphic on how that works, how the mRNA teaches your cells to make copies of that spike protein, so that if you encounter the real virus later, your body is prepared to fight it off. The vector vaccine is similar. It doesn't use messenger RNA. Instead, it uses a harmless adenovirus vector that's one of the common cold viruses. Not all of those are benign, but this one is, and it stimulates your body's immune response by delivering a part of the spike protein to the cell so that you can create that immune antibody. The vaccines cannot give you COVID. There's no COVID virus in them. How many people have been vaccinated in the United States? 163 million people have been fully vaccinated. It is an amazing number. And you can see it varies by age quite a bit. So in terms of the total population, the percent that's fully vaccinated is about 50% in this as of July 27th. Everybody 12 and up is eligible for vaccination with the Pfizer vaccine, 18 and up for all the others. Older people in general are more protected, which is appropriate. You know, they were suffering the largest severe side effects of the disease. So we're really gonna save a lot of lives by having them very protected, with 80% of people over 65 being fully vaccinated. And you can see by the type of vaccine, the data, millions of vaccinations have been given. Even in South Carolina, we've done a good job. We need to do better, but we've done a great job of getting people protected. The total fully vaccinated population is about 44% of people, 1.9 million. And by age and gender and race, or sex and race, we have a breakdown here, also mirroring the national statistics of the older populations have been more vaccinated. Younger people remain relatively unprotected by vaccination. How do we know vaccines are safe? Well, first, we've had huge numbers of people receive these vaccines. We have a system called the Vaccine Adverse Event Reporting System, or VAERS, that's online, that is acquiring tremendous amounts of data, and it's actually required that it's reported to the VAERS system anything that might remotely be linked to these vaccines. So if somebody dies within a certain time frame after receiving a vaccine, it's reported. And anybody can go on there and see those numbers. The problem is that it doesn't really tell you what the cause of those events were. That's really where, experts, medical experts go in and try to look at the actual data and determine, was this something that was out of the ordinary and related to the vaccine itself? It's not always straightforward to do that, but this system is actually functioning very well for the COVID vaccine. More event reports have been given and looked at, and it's really identifying signals early if there are issues. So this is also there. Anybody can go on and look at it. These are unverified reports of illnesses, and that's important to understand because it's still important that those are entered. So I'm not trying to say that that's not a good thing. We need transparency. This is really transparency, trying to identify every possible issue. Now, I know the next slides are really busy because I merely just cut and pasted them, but I thought it would be important if anybody wanted to go back and read it. So reports of the death are rare after, this was after 340 million doses of vaccines were administered, 6,000 reports of deaths. So a very small percentage of deaths of the numbers of people who receive vaccine. Those were required reports because the FDA and scientists want to know if there's a problem. We need to know early. So there's one link that's been shown to happen in rare instances with this unusual clotting problem called thrombocytopenic thrombotic syndrome, vaccine-induced, that's related to the COVID-19 Janssen. And that's a plausible, rare, and serious adverse event. We've seen something very similar to that when we use a medicine that's commonly used in the hospital called heparin to thin people's blood. Sometimes people get an autoimmune reaction that actually triggers clots in an unusual way. Anaphylaxis, or the most severe form of allergy after a COVID vaccination, is rare. It happens only in 2 to 5 persons per million vaccinated. There are no preservatives in these vaccines. there is polyethylene glycol or polysorbate. So rarely there's some people who have a reaction to that, but it's extremely rare. More recently, there was a report of Guillain-Barre syndrome after people had received the Johnson & Johnson vaccine. Very few reports, right? 137 preliminary reports and 13 million doses. So extremely low risk. And I will say that Guillain-Barre syndrome has been linked to COVID itself too. So COVID itself causes tremendous disease in many people. So the chances are much more of severe disease with COVID than, I think so far than what we've seen with the vaccines. So this Guillain-Barre syndrome has been reported about 2 weeks after vaccination, mostly in men, especially 50 and over. It is an autoimmune response that leads to damage in nerve cells. Guillain-Barre syndrome happens after infections, other infections besides COVID too. I've seen it in the hospital. As I talked about before, the thrombosis with thrombocytopenia syndrome has been identified. At least 39 people had been identified as receiving that. It was especially in younger women. So it might be, for people who are concerned, might have some other risk factor, they would talk to their doctor and perhaps choose an alternative vaccine. There were only a couple of cases after an mRNA COVID vaccination. And just we're talking out of hundreds of millions of doses of mRNA vaccines. The myocarditis and pericarditis risk after a vaccination is rare. It was linked to vaccination in people 30 and younger, particularly adolescent males. So far there have been 699 reports. And I want to just say, it wasn't just through the VAERS system. The CDC actually outreached through the state health department, said, please consider this diagnosis, send us the reports so that we can know. So that's what we call like enhanced surveillance. When there was a signal, they said, we need to know if this is a true consequence or not. Myocarditis, I already talked about it a little bit with the athletes who had, 5 athletes out of the 700 who had it identified. The type that happens, that's been identified right after the Pfizer Moderna, has so far not led to any known severe illness, except, it's severe because the people end up in the hospital. So they end up in the hospital with chest pain and some shortness of breath. But they've gotten better on average within a week and seem to be okay. We're not sure what the long-term consequences of that are. But again, it's a small number compared to the people who have gotten severely ill and have long-term consequences from COVID. It's always a balance of risks and benefits with every choice we make in life. Scientists, so the American Heart Association, the American Academy of Pediatrics, CDC all looked at this and issued a statement that the benefits of the vaccine outweigh the likely harm. So the likely benefits are bigger, and they tried to look at numbers, estimates of how many people who would get the vaccine would have this adverse consequence of myocarditis versus how many cases of COVID and hospitalizations would be prevented. The age range that was more at risk for myocarditis or pericarditis was that of 12 to 17-year-old males. And you can see here the numbers on this table. The COVID-19 cases prevented were estimated as 5,700, and that's for a million second dose vaccines of over a span of 120 days, they're estimating what would we expect. So they would prevent maybe 200 hospitalizations, 71 ICU admissions, and deaths too, for giving 1 million second dose vaccines to that age range. Myocarditis cases that might be expected would be 56 to 69. So there would be some individuals who would have a bad outcome. But those myocarditis cases have been largely treatable and have gotten better. And that's why the cardiologist, the American Heart Association, has issued a statement saying that they think that the vaccine is safer than the risk of getting COVID. This is an attempt to visualize what it would mean. And we used that for 12 to 17-year-olds because of boys, because that was the age range where there would be the greater risk of myocarditis by the data what we have. And I should say that it's not really clear, but for some reason in general, myocarditis, it seems to group in that age range of young adolescent males. And myocarditis is known to be triggered by other viruses like Coxsackie virus, flu virus, adenoviruses, in addition to toxins and autoimmune issues. So 5 to 6 might experience that out of 80,000. Now, alternatively, if they weren't vaccinated in that stadium, 456 of those 80,000 boys would get COVID, 18 would be hospitalized, 6 would end up in the ICU. None of them would die probably over the next 3 months, but still there would be a lot of illness. And there would be secondary infections and perhaps long-term consequences like fatigue or other brain fog issues that have been identified in many people. So again, how safe are the vaccines? Well, more than 161 million people have been fully vaccinated. Very few rare adverse events have been linked. The vast majority of vaccine recipients, they had fatigue, arm pain, maybe some chills as their body mounted an immune response. That's all I had, I know. So I want to make sure I address this. I think I'm running out of time. I'm getting this hint. There has been studies, there's no impact on fertility observed. It seems extremely unlikely. We use this method to check for women who agree to follow up women who've been pregnant. They've got a pregnancy registry. They've been checked in terms of outcomes. There's been a study published. Pregnant women didn't seem to be at any more risk of any severe consequence. In fact, the VSafe surveillance system has pretty much shown that, this is tens of thousands, right, of people who've been pregnant during the vaccination, and there's been no increased risk of preterm, birth, stillbirths, congenital anomalies. So far, things look very safe. There have been meta-analyses that have looked at it. It looks extremely safe. There's many studies, however, that have documented the increased risk of severe COVID disease in pregnancy. So pregnant women in general were excluded from the vaccine trials, but the theoretical risk of fetal harm from these authorized vaccines is low. And then we've already seen, all this data come out now of women who've been vaccinated, doesn't seem to cause any illness that's excessive. But we do know that pregnant women are at higher risk of severe COVID-19 disease. That's why the Society for Fetal and Maternal Medicine and the American College of Obstetrics and Gynecology have been recommended that pregnant women be offered this vaccine. So everybody almost should be getting this vaccine who hasn't been vaccinated. There are a few contraindications. Specific medical conditions may warrant a review with your personal physician about the timing of the vaccine or the type of the vaccine. I don't want to, I don't want to discount that these are individual decisions, but really, for vast majority of people, the potential benefits outweigh the potential risks. I should say too, if there's any concern about male infertility, they have been looked at that in a small study, didn't see any change in that. So again, we weigh benefits and risks of things all the time. Getting in the car is dangerous. The vaccines are 90% effective. I think our data shows that they're but pretty effective, very effective at severe disease, and looking very effective even though we have the Delta variant. Hopefully we won't have any new variants that come out, new mutations that are more resistant to our efforts. And we really have to weigh these benefits and risks carefully. Where can you find good information? Well, you can go to, I'm plugging my alma mater, Johns Hopkins, but they have an excellent coronavirus resource center that actually has animated videos about the virus, about all sorts of things. They also show, of course, a global map of disease burden, an excellent resource. The CDC has excellent resources that are trusted by physicians and public health professionals trying to do the best that we can to help protect and prevent disease, protect the community, prevent disease. DHEC, that's who I work for. We're trying, to do the best we can to prevent disease and monitor our progress. Infectious Disease Society of America, if you really want to get into the science, they have some excellent webinars and resources free for everybody. United States FDA tells you a lot about the vaccine development and information that's useful. And of course, if you want to get a vaccine, you can come, I think tomorrow, they're going to have a vaccine clinic there that would be excellent, or you could go to your doctor's office if they offer it, or some other vaccine location, which you can find through the DHEC website, Vax Locator. And I think I will stop there. I appreciate your time and everything. All right.
Thank you, Dr. Carlson. We really appreciate it. I'm going to turn it over to Lisa LaFay for just a few seconds. She can talk about the vaccine clinic tomorrow and a little bit about some of the questions.
Thank you so much. I really appreciate your talk, Dr. Carlson. Yes, we will have, DHEC is coming tomorrow to the Wellness Center. They'll be here from 9 until 1, offering both the Moderna and the Johnson & Johnson or Janssen vaccine, your choice. And then we'll work with them to set up additional clinics as needed as we move into the school year. And in addition, some of the questions were answered in the slides, just so you guys know, that were submitted, but they were just incorporated into the discussion. I know I've gotten questions several times about fertility and whether the vaccine will affect that or not. And so those were just incorporated in. But again, as I said at the beginning, we will do an FAQ page. So please submit additional questions. We'll take the questions that we've gotten, we'll answer them. Many of them are Wofford specific, which is why we didn't want to handle them here. It's better to put them out there in a page where someone can go and just read them. So just thank everyone so much for attending and listening. And we will get that page to you probably in the next 2 weeks. It won't happen like tomorrow. It takes a little bit of time to put that sort of thing together. So please be patient, but we will get those. So please submit additional questions, covid@wofford.edu. Thanks so much.
All right, this concludes our evening. Thanks for joining us. Take care and have a good night.